Hey, what's up, fellas? This video is for Jason, who has requested a dirty waste oil burner that can burn the dirtiest stuff you can imagine without clogging up. That's the goal. These things are hard to build cheap. It costs a lot of money to get one of these things to work and be self-cleaning and be able to run for hours and hours without clogging up. The ones built for actually doing this, from the people I know that have actually bought them, don't work. You can't burn dirty waste oil in them, only good waste oil.
All right, fellas, let me give you a quick explanation of what we got going on right here. This back chamber is separated from the main combustion chamber, and that duct allows a jet of fire to pass through that duct. We then channel that fiery exhaust gas through these side ducts. These side ducts help preheat the combustion chamber. They help keep it hot. They help vaporize the dirty oil and burn away any carbon buildup that may take place.
Okay, you see there the red hot back end. You see the separated chamber, how it's red hot? That sucker also helps preheat the incoming air. And here are the discharge ducts. I got the fuel set so you can see it. This isn't the ideal operating setting. I just wanted you guys to see that gas jets do in fact pass through those ducts. And it does help heat the combustion chamber. Without this feature, we're really running a cold back end on the combustor, and that is far from ideal.
Running so much hotter now. It's definitely self-cleaning now. Alright guys, so running like this, the thing's 100% self-cleaning. It will not build up to detrimental amounts like this, from what I can see so far. Turn it back up though, to a higher heating power. Okay, Jason, so this is what I came up with, brother. And it's pretty badass, if you'll excuse my French. I'm very impressed with how well the forward ducts worked out. Not only do they preheat the canister, which is essential to the atomization of the fuel, but it definitely was pretty cool having those 4 flames shooting out the front with that center fire. And without having this rear fire burner, the whole thing cools down too much. You only get red hot in the very front, and this whole area will be cold because of the air. So some past experimentation about 5 years ago showed that having a discharge duct in the back of this thing drew that central fireball to the rear of the device and heated everything up. So I'll throw a price together for you on this thing, Jason. Now this ain't the transformer you would want to use. This is like a $250 transformer I have here. That's not ideal. That's my experiment transformer. So we'd have to get you a 12-volt transformer or, you know, like a battery charger or something to run this pump. But it took about 3.5 hours to build this thing. There is a lot of parts to this thing. Well, not really. There's the cutout pieces. But just cutting these ribs and welding them on. I mean, that's like a 500-foot weld, man. It takes a long time and a lot of gas. This bottle of gas costs about $350 some. So I have to include the gas. See where I started here? I use that much gas pressure. So that's probably about 25 bucks in gas. Hard to say. I would imagine it is. Look at the welds on this thing. It's like, geez, you could wrap these around the planet 3 times. So, but there it is, man. This thing would basically mount faceward into like some special opening. You'd have to cut a special opening for this thing, and you could just bolt it right to the front of your furnace so that this part's external and you're getting that infrared heat going out into your shop. We'll have to talk about mounting. That was my idea, is you'd have a hole cut in the front of your furnace, or I could set you up with a better face plate. But I'll get you a price on this thing as soon as I can. I got to add up all the cost of all this material and the 3.5 hours of time it took to build it.